Dear students, Assalamu alaikum. My name is Mohammad Farhan and today our lecture is mass energy equation, which is of chapter number 6, work and energy. Students, Einstein predicted that interconversion of mass and energy is possible. It was considered to be his best work when he gives an equation which is known as mass energy equation, which was E is equal to mc square. Students, mass can be converted into energy, and like a reversible reaction, energy can also be converted into the mass. With a very less amount of mass, we can create a very large amount of energy, because a loss of a mass is a result of production of energy. Students, I give you an example. 1 kg of coal can produce 8 kilowatt electricity. 1 kg of coal produces 8 kilowatt of electricity. But 1 kg of uranium 235, it can produce 24 million kilowatt of electricity. Now compare this figure, 24 million and only 8 kilowatt. You can see that when we use uranium for the production of electrical energy, it can give us 24 million kilowatt of energy. Similarly, same amount of coal gives us only 8 kilowatt of electricity. 24 million and 8 kilowatt, this is the difference. Students, this energy equation, this mass energy equation is used in our nuclear plants. Nuclear substances such as uranium and other nuclear substances are used, and by their fusion and fission reaction, energy is produced. So this equation means that mass can be converted into energy, and similarly energy can be converted into mass. Because we know that, students, energy can never be destroyed. We know that energy can never be destroyed. So when some mass is converted into energy, that mass is converted into a lot of different forms of energy. For example, if we burn a wood as a fuel, what things we are going to get? We get heat energy, we get carbon dioxide, we get its ash. So that wood, that mass of wood is burned and we get 3 forms: heat energy, carbon dioxide and its ash. So if we combine all these things, if somehow it cannot be possible physically, but if somehow we can bring back all the things, its ash, its heat energy and carbon dioxide, and every gases when wood is burned is released, if we combine all of the things, we can get the original form of wood back. So remember, students, mass can be converted into energy and energy can be converted into the mass. And with a very small amount of mass, we can create a lot of amount of energy. Like I said here, 1 kg of uranium can produce 24 million kilowatt. So the purpose of telling you the difference between coal and uranium is, this equation is used in nuclear plants where nuclear substances are used. Uranium is a nuclear substance. It emits nuclear radiation. So this equation is successful, and this equation is full capable, and this equation is full applicable in nuclear plants where we can use nuclear elements and convert their nuclear radiations into the energy of our requirement. So students, this equation was the Einstein best work. He got a Nobel Prize for this equation, is equal to mc square. In this equation, E is energy, M is mass, and C is the speed of light, which is given as 3 multiplied by 10 raised to the power 8 meter per second. So students, remember that E is equal to mc square is Einstein's best work. Students, this equation, this chemical equation is happening in sun and in stars for millions of years. Students, remember the energy we are getting from sun. This is a very less fraction of energy which is reaching the earth. A lot of energy is dissipated near the sun. A very less fraction of energy is coming to the earth, and that fraction of energy which is coming from the sun to the earth is the main cause of the life on this planet earth. Only that less fraction. And this equation is equal to mc square. This chemical equation is happening in the sun and stars for millions of years. Nuclear reactions are occurring in sun and in stars. That's why it is a burning ball of fire, because in sun a lot of millions and trillions of reactions are happening, and those reactions are, a lot of those reactions are, according to this equation, is equal to mc square, and those nuclear reactions are the main cause of life happening on earth. Now students, our topic is electricity from fossil fuels. Students, in our houses, in our offices, a lot of electricity is used, and most of that electricity is produced from burning fossil fuels, and that is a topic which we are going to study, that electricity from fossil fuels. Students, what kind of fossil fuels are used for the production of electricity? Coal, oil, gas, these all are the fossil fuels which are used. These fossil fuels, coal, oil, gas, are burned in thermal power plants. They produce heat energy, and from that heat energy we use different processes for the production of electricity. Students, remember, when fossil fuels are burned to the electricity production, in all these processes, a lot of forms of energy is converted from one form to the other. This is not the single process that we burn of fossil fuels and electricity is produced. No. From the burning of fossil fuel to the production, to the final production of electricity, a lot of energy conversion occurs, and that I'm going to explain with the help of this block diagram. Students, our first step, chemical energy stored in fossil fuels as input. Students, when fossil fuels, and what is the process? Burning process. Students, fossil fuel is burned in thermal power plants. When fossil fuel is burned, a lot of chemical energy is given as an input. We studied in previous lectures that when we burn fossil fuels, carbon dioxide is produced along with the heat energy. We also know that when it combined with oxygen, water and heat energy is produced. A lot of things are produced when the fossil fuel is burned. So the first step is chemical energy stored in fossil fuels. Because why I am saying this, that chemical energy, students, we have studied in previous lectures that the burning of fossil fuel is a chain of chemical reactions. So when it is a chain of chemical reactions, so that energy which is stored in the fossil fuel is a form of chemical energy. So first step is chemical energy stored in fossil fuels is used as input. How it is used? Burning process. We burn the fossil fuel and the chemical energy is produced. Second step, when fossil fuel is burned, heat energy is produced. We know that heat energy is used to produce high pressure steam in a boiler. Students, whenever heat is produced, we use heat energy for different purposes. But in this step, we are using heat energy for the production of steam, for the production of high pressure steam. So heat energy is used to produce high pressure steam in a boiler. Now, what is the step? Changing potential energy into the mechanical energy. When this high energy, high pressure steam is given to turn a turbine. Step number 3. Third step. Steam is produced. Now this steam is going to be used to turn a turbine. Now potential energy of steam is given to the turbine. Now when a potential energy of steam is given to turn a turbine, this is potential energy changing into mechanical energy, because the turning of turbine is a mechanical form of energy, and the steam given to the turbine is possessing a potential energy. So steam possesses a potential energy, and turning of turbine is mechanical energy. So when steam is given to a turbine, we are changing potential energy of steam into mechanical energy of turbine. So third step is potential energy of steam is used to turn a turbine. So when potential energy of steam is used to turn a turbine, this is changing potential energy to mechanical energy of turbine, mechanical energy to turn the turbine. So chemical energy, from chemical energy we get steam. Steam is used to turn a turbine. Now what is fourth step? Fourth step is we have turned the potential energy of steam into mechanical energy of turbine. Now fourth step is mechanical energy. Mechanical energy of turbine is used to run electric generator. Same process which I have told you in the topic of hydroelectric power plant. The flow of water from some height is provided to turn the turbine, and electric generator is attached to the turbine. When mechanical energy of turbine occurs, mechanical energy of turbine converted into electrical energy with the help of electric generator. Same process is happening here, but in this case we are turning the turbine not from water, not from falling water, not from the potential energy of water. We are turning the turbine from potential energy of steam, which we produce from the heat energy of fossil fuels. So potential energy is converted to mechanical energy. Now mechanical energy of turbine is used to run electric generator. Now in this process we are transferring mechanical energy. We are transferring the mechanical energy of turbines through electric generators. We transferred the mechanical energy of turning turbine to electric generators. So mechanical energy from turbine is used to run electric generator. Now mechanical energy, final step, mechanical energy into electric energy. Final step is that electricity output, electricity as a result, final result. Result final is electricity output from electric generator. In this step, mechanical energy is converted finally into the electrical energy. So students, I have told you that when fossil fuel is burned to the final production of electricity, a lot of energy conversion occurs. I am going to summarize this. Fossil fuel is burning process. From fossil fuels, heat energy is produced and high pressure steam is produced in the boiler. This is when this steam is provided to the turbine. This is changing potential energy of steam into the mechanical energy of turning turbine. Then this mechanical energy is transferred to the electric generator. So this transferring of mechanical energy to electrical generator produce final electrical energy. So students, watch out for the conversions: chemical energy, heat energy, potential energy, mechanical energy, and electrical energy. See how energy changes its form from one step to another. In this step, heat energy. In this step, fossil fuels, chemical energy. In this step, heat energy. Chemical energy, heat energy, potential energy, mechanical energy, and electrical energy. See students how energy changes its form from one form to another in each and every single step. So this is the electricity production from fossil fuels. Thank you so much.